and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to calculate the mass needed for a given number of moles of a compound. In the last video, we saw that we can calculate the number of moles of a compound in a given mass by using this equation. The number of moles equals the mass in grams divided by the relative formula mass. In this video, we're going to see how to calculate the mass needed for a given number of moles. Here's a sample question. Calculate the mass of 4 moles of sodium chloride, and sodium chloride has the formula NaCl. In order to calculate this, we need to rearrange the equation to calculate mass, and here it is. The mass in grams equals the number of moles multiplied by the relative formula mass. So let's look at how we answer the question. First, we need to calculate the relative formula mass of sodium chloride. We've got 1 atom of sodium, and the relative atomic mass of sodium is 23. We've also got 1 atom of chlorine, and the relative atomic mass of chlorine is 35.5. Adding these together gives us a relative formula mass of 58.5 for sodium chloride. So now we can go back to our equation and answer the question. The mass in grams is the number of moles multiplied by the relative formula mass. So we've got 4 moles multiplied by 58.5. This gives the total mass of sodium chloride of 234 grams. Here's a question for you to try. Calculate the mass of 3 moles of potassium oxide. The formula of potassium oxide is K2O, and I've given you the relative atomic masses that you need. You should pause the video now and try this yourself. Okay, first we need to work out the relative formula mass for potassium oxide. We've got 2 atoms of potassium, and potassium has a relative atomic mass of 39. We've got 1 atom of oxygen, and oxygen has a relative atomic mass of 16. Adding these together gives us a relative formula mass of 94. So now we can go back to our equation. We've got to calculate the mass of 3 moles of potassium oxide. So we multiply the number of moles by the relative formula mass. And this gives us a final mass of 282 grams. Here's another question for you to try. Calculate the mass of 0.1 moles of cesium nitrate. Cesium nitrate has the formula CsNO3. I've given you the relative atomic masses that you need, so pause the video now and try this yourself. Okay, so first we'll work out the relative formula mass of cesium nitrate. We've got 1 cesium atom, and cesium has a relative atomic mass of 133. We've got 1 nitrogen atom, and nitrogen has a relative atomic mass of 14. Finally, we've got 3 oxygen atoms, and oxygen has a relative atomic mass of 16. Adding all of these together gives us a relative formula mass for cesium nitrate of 195. Going back to our equation, we can now calculate the mass of 0.1 moles of cesium nitrate. So the mass is the number of moles multiplied by the relative formula mass. Multiplying 0.1 by 195 gives us a mass of 19.5 grams, and that's our final answer. Okay, here's one final question for you to try. Calculate the mass of 5 moles of copper sulfate. The formula of copper sulfate is CuSO4, and I've given you all of the relative atomic masses that you need. You should pause the video now and work this out for yourself. Okay, we'll start by working out the relative formula mass of copper sulfate. We've got 1 atom of copper, and copper has a relative atomic mass of 63.5. We've got 1 sulfur atom, and sulfur has a relative atomic mass of 32. And finally, we've got 4 oxygen atoms, and oxygen has a relative atomic mass of 16. Adding these together gives us a relative formula mass for copper sulfate of 159.5. Going back to the equation to calculate the mass, we multiply the number of moles by the relative formula mass. This gives us a final mass of copper sulfate of 797.5 grams. You'll find plenty more questions on calculating the mass of a given number of moles in my revision workbook, which you can get by clicking on the link above. Okay, so hopefully now you should be able to calculate the mass needed for a given number of moles of a compound. Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to use moles to balance chemical equations. This is for the higher tier only. We've already looked at balancing chemical equations in a previous video. In that video we used counting atoms to balance equations, but in this video we're going to use moles. It's fairly straightforward if you learn the method. I'm going to start with an easy example. This shows the reaction between hydrogen and chlorine to make hydrogen chloride. The question tells us that 2 grams of hydrogen react with 71 grams of chlorine to make 73 grams of hydrogen chloride. We're going to use that information to balance the equation. The first thing we need to do is calculate the number of moles of all of the chemicals in our reaction. Remember that the number of moles is the mass divided by the relative formula mass. We've got 2 grams of hydrogen, and hydrogen has a relative formula mass of 2. This means that we've got 1 mole of hydrogen. I'm going to show that by putting a 1 in front of the hydrogen like this. We've got 71 grams of chlorine, and the relative formula mass of chlorine is 71, so that means that we've got 1 mole of chlorine. I'm going to show that by putting a 1 in front of the chlorine like this. Okay, we've got 73 grams of hydrogen chloride, and the relative formula mass is 36.5, so we've got 2 moles of hydrogen chloride. And again, I'm going to show this by putting a 2 in front of the hydrogen chloride like this. Now we're almost finished. We've now got to look again at the large numbers. We've got to make certain that these numbers are the lowest possible ratio. To do that, we divide all of them by the smallest number. So in this case, the smallest number is 1. Starting with the hydrogen, dividing 1 by 1 gives us 1. With the chlorine, again dividing 1 by 1 gives us 1. And with the hydrogen chloride, dividing 2 by 1 gives us 2. So as we can see, these numbers are already the lowest possible ratio. This means that this equation is now fully balanced. All we have to do now is remove the number 1 in front of the hydrogen and the chlorine, as we don't write 1 in chemical equations. Now, you might be thinking, what's the point of balancing equations using this method, especially easy ones such as this? Well, this method works really well when the equation is more complicated, such as this one. 54 grams of aluminium reacts with 216 grams of iron 2 oxide, forming 102 grams of aluminium oxide and 168 grams of iron. Balance the equation. You should pause the video now and try this yourself. Okay, first we need to calculate the number of moles of all of the chemicals, and I'm showing you these here. We've got 2 moles of aluminium, 3 moles of iron 2 oxide, 1 mole of aluminium oxide, and 3 moles of iron. Now we've got to work out the ratio of these numbers by dividing by the smallest number. In this case, the smallest number is 1. 2 divided by 1 is 2, 3 divided by 1 is 3, 1 divided by 1 is 1, and finally 3 divided by 1 is 3. So that means that these are our balancing numbers, and we can put them into the equation like this. Remember that we don't write 1 in chemical equations. Here's a final example for you to try. 1,248 grams of barium chloride reacts with 684 grams of aluminium sulfate, forming 1,398 grams of barium sulfate and 534 grams of aluminium chloride. Balance the equation. This looks tricky, but it really isn't if you follow the method. Pause the video now and try this yourself. Okay, first we need to work out the number of moles of all of the chemicals involved, and I'm showing you these here. We've got 6 moles of chloride, 2 moles of aluminium sulfate, 6 moles of barium sulfate, and finally 4 moles of aluminium chloride. Next, we work out the ratio by dividing all of these numbers by the smallest number. In this case, the smallest number is 2. 6 divided by 2 is 3, 2 divided by 2 is 1, 6 divided by 2 is 3, and 4 divided by 2 is 2. These are the numbers which we use to balance our equation, so I'm putting them into the equation here, and don't forget that we don't need to write the number 1. Remember that you'll find plenty more questions on using moles to balance chemical equations in my revision workbook, which you can get by clicking on the link above. Okay, so hopefully now you should be able to use moles to balance chemical equations. Hi and welcome back to freesciencelessons.co.uk. By the end of this 2-part video, you should be able to use Avogadro's constant to calculate the number of molecules and atoms in a given sample. This work applies only to higher students, so if you're doing foundation you don't need to do this. Now I'm going to be honest with you, some of this is pretty challenging. Please trust me that you can do this and don't give up. You might need to watch the video a couple of times. We've been looking at moles and we've already seen that 1 mole is simply a shorthand way of saying this number. Scientists call this number Avogadro's constant. Normally we write this in standard form, which is 6.02 times 10 to the power of 23. Before we start working with Avogadro's constant, we're going to look at how we can calculate the number of moles of atoms in a given number of moles of a molecule. Here's a sample question. Calculate the number of moles of atoms in 1 mole of water molecules, and water has the formula H2O. Looking at the formula, we can see that 1 molecule of water contains 2 atoms of hydrogen and 1 atom of oxygen, so that makes 3 atoms in total. So if 1 molecule of water contains 3 atoms, then 1 mole of water molecules must contain 3 moles of atoms. Here's one for you to try. Calculate the number of moles of atoms in 1 mole of methane molecules. Pause the video and try this yourself. We can see that 1 molecule of methane contains 1 atom of carbon and 4 atoms of hydrogen. In other words, 5 atoms in total. Because 1 molecule of methane contains 5 atoms, we know that 1 mole of methane molecules must contain 5 moles of atoms. Try this one. Calculate the number of moles of atoms in 1 mole of calcium hydroxide. Pause the video now and work this out. Okay, we can see that 1 molecule of calcium hydroxide contains 1 atom of calcium, 2 atoms of oxygen, and 2 atoms of hydrogen, so 5 atoms in total. So we know that if 1 molecule of calcium hydroxide contains 5 atoms, then 1 mole of calcium hydroxide must contain 5 moles of atoms. Okay, so now that we can calculate the number of moles of atoms, we're ready to start working with Avogadro's constant. Take a look at this question. Calculate the number of atoms in 1 mole of hydrogen chloride. You'll notice that now we're asked for the number of atoms, not the number of moles of atoms. Remember that 1 mole of hydrogen chloride contains Avogadro's constant of molecules. In other words, 6.02 times 10 to the power of 23. The formula of hydrogen chloride is HCl. This means that 1 molecule of hydrogen chloride contains 1 atom of hydrogen and 1 atom of chlorine, so 2 atoms in total. So what this means is that if we have 6.02 times 10 to the power of 23 molecules of hydrogen chloride, we must have 2 times that number of atoms. So in other words, we must have 1.204 times 10 to the power of 24 atoms. Here's one for you to try. Calculate the number of atoms in 1 mole of sodium oxide, Na2O. Pause the video and try this yourself. Okay, 1 mole of sodium oxide contains 6.02 times 10 to the power of 23 molecules of sodium oxide. In other words, Avogadro's constant. Looking at the formula of sodium oxide, we can see that 1 molecule contains 2 atoms of sodium and 1 atom of oxygen. In other words, 3 atoms in total. Therefore, we need to multiply the number of molecules of sodium oxide by 3 to get the number of atoms in 1 mole of sodium oxide. This gives us a final answer of 1.806 times 10 to the power of 24 atoms. You'll find plenty more questions on using Avogadro's constant in my revision workbook, which you can get by clicking on the link above. In the next video, we'll continue exploring how to use Avogadro's constant to answer more complicated questions. Hi and welcome back to freesciencelessons.co.uk. By the end of this 2-part video, you should be able to use Avogadro's constant to calculate the number of molecules and atoms in a given sample. Remember that this work applies only to higher students, so if you're doing foundation, then you don't need to do this. In the last video, we saw that 1 mole is also called Avogadro's constant, and it has a value of 6.02 times 10 to the power of 23. we learned how to calculate the number of atoms in a given number of moles of molecules. In this video, we're going to take this one stage further. We're going to learn how to calculate the number of atoms in a given mass of a chemical. Here's a sample question. Calculate the number of atoms in 48 grams of magnesium. As you can see, we've not been given the number of moles. We need to calculate this from the mass, and we use this equation, which we've seen in a previous video. The number of moles equals the mass we're given in grams divided by the relative atomic mass. So we've got 48 grams of magnesium, and the relative atomic mass of magnesium is 24. Remember that you are given all the numbers that you need in your exam. So this means that we've got 2 moles of magnesium. Remember that 1 mole is Avogadro's constant, which is 6.02 times 10 to the power of 23. Therefore, in 2 moles of magnesium, the total number of atoms is Avogadro's constant multiplied by 2. This gives us a final answer of 1.204 times 10 to the power of 24 atoms. Here's one for you. Calculate the number of atoms in 28 grams of lithium, and the relative atomic mass of lithium is 7. Pause the video and try this for yourself. Okay, so first we need to calculate the number of moles of lithium that we have. 28 divided by 7 tells us that we've got 4 moles. Remember that 1 mole contains Avogadro's constant of atoms. So to calculate the number of atoms, we multiply 6.02 times 10 to the power of 23 by 4, which gives us a final answer of 2.408 times 10 to the power of 24 atoms. Now you could be asked to work out the number of atoms in a compound, and that's also fairly straightforward. Here's a sample question. Calculate the number of atoms in 56 grams of calcium oxide. This has the formula CaO. Now calcium oxide is a compound, so to calculate the number of moles, we need to use this equation. The number of moles is the mass in grams